Today's episode is sponsored by Jam.dev. It's developer-friendly bug reports in 2 clicks. It's free and it's fabulous. You're a dev, you work on a team, maybe your team sends you bug reports with no details, maybe text, no screenshot, no console logs, and you end up going back and forth just to get the repro. That's when we introduce Jam.dev. It's a free tool that saves developers a ton of frustration. It'll force your teammates to make the perfect bug report. They literally can't do it wrong because it automatically includes a video of the bug, console logs, network requests, all the information you need, even their network speed. It's super easy to use. It works in Chrome. It works in Edge. They see a bug, they click a button, it makes a ticket, it saves time for them, and it'll save you a lot of hopping on calls and meetings to debug. If you're an engineer and you'd rather spend your time writing code than responding to comments, send your team jam.dev. And for the Hansel Minutes listener, take a look at jam.dev/Scott. Get started with your first year completely free. That's jam.dev/Scott. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Brit Myers. She's the VP of Engineering at System Initiative. How are you?
I'm good. How are you?
I am chillin' and happy to be chatting with you about System Initiative. You're removing the paper cuts from DevOps. And as I always mention when I have folks on the call, I go into their LinkedIn and I look at how impressive people's LinkedIns are. They're always more impressive than mine. And I love it when people's LinkedIns give me a sense of like history, because so many of us were here, have been here as history gets made. Because right now, DevOps is the thing that everyone says, it's in everyone's mouth, but it didn't always get called DevOps. And I can see that in your LinkedIn, because it's like continuous delivery is what it was called like 5 years ago. And you kind of keep scrolling backwards and backwards and backwards. It has different names, but it's all the same. How did you get involved in what we now call DevOps?
Yeah, it's funny because I would say my journey to DevOps was stumbling on problems, not having words for it, and then discovering that somebody else had the same problem and had a word for it, and then sort of like latching onto those things. So it was incredibly organic. I didn't know that DevOps was an answer to a question that I had. I knew that delivering software was painful. And so I started there, and it was like, okay, what can we do? When you start sort of researching and seeing what's going on and not wanting to reinvent any wheels, but incredibly organic. So I've not been at either the forefront or I would say like a laggard. I've been sort of in that in between where like sometimes I felt like I've been leading the charge a bit, not from a sort of industry perspective by any means, but having the capacity to experiment in things that maybe haven't been tried as much, as well as sort of, this has worked well here. I'm going to do it and try to replicate it and see how far I can get. And I've bounced between that basically my whole career.
You said, though, that delivering software is hard. And I think that's significant that you phrased it like that, because writing software is hard, testing software, but it's delivering. It's that last mile that people don't talk about.
That was the first problem I needed to solve. So I was a software engineer by trade, but it's pretty much on accident in that like I never was really exposed to computer science or tech through high school. I knew I liked engineering and that I liked solving problems creatively. I went to go be a civil engineer because my grandfather was, and I didn't really know about any other type of engineering. And I did not get into the engineering school that I'd applied to. Found myself as a math major, which there's a lot of overlap with CS. Discovered computers, discovered writing software. And, as I sort of tracked my leadership curve, the problem in front of me was we needed to deliver software. And that was like the first paper cut because writing software is hard, but that wasn't the hardest part. That wasn't the bottleneck. Figuring out what to solve, like that wasn't the bottleneck. The first bottleneck I ran into was shipping. That was it. And that sort of kicked off basically the last decade for me.
Isn't that the personality type, though, of the developer, where it's just like, I've seen a problem. You get nerd sniped, and you're like, you join the team, right? You may have joined as an intern or a junior or whatever, and you go, okay. They throw you into this hot boiling pot, and you go, this is awful. But then you realize what's awful is the build server is awful.
Mm-hmm. Yes. Not only like the build server is awful, and you can sort of insert any example there of like what the thing is that stands in your way. And the first thing you do is try to empathize and like, well, okay, clearly it's not awful on purpose. Like nobody designed any of these things to be awful. So why actually are they awful? And you kind of keep shifting right in terms of, all of the steps that it takes before a user can actually use a piece of software. And all of my like empathetic alarms go off as the further right I got. The things that those people needed to solve, they couldn't. And so they were just sort of living with what was given to them with no ability to change their own destiny, if you will. So for example, if what is needed is a significant architectural change, they're not necessarily the people who are going to go implement the significant architectural change that's going to make it so that we can parallelize builds in this way or run tests in this way. Those aren't the people that are necessarily writing the test frameworks that are cause a 12-hour nightly build. That's not what they're doing. And so therefore, if somebody else can't, if we can't figure out how to solve that problem, what do you do about it? And so it was just so interesting to me that so many of these problems, the people who suffered, they were not autonomously able to go fix it. Like they could not just get through it themselves. You needed to bring everybody together to do it. You just kind of walk your way down, and that just kept happening over and over again, where the feedback to the sort of further right down the pipeline, if you will, wasn't happening, but you also weren't getting feedback early enough in the process. And all of that compounds, and you end up with a 12-hour build on a crappy build server that nobody's really very proud of or feels good about, with no silver bullet to sort of make all of that go away and fix all those problems, And that's just those paper cuts just exist at sort of every step where something has to happen, A, B, C, D, in between each of those points, whether they're a handoff between human beings or not. It's an opportunity for something to get disrupted and a decision to be wrong. And so, yeah, those are the paper cuts that you stumble into. The further I got into this problem, it was just everywhere across. And this is, by the way, across, I spent almost a decade at an enterprise software company that's headquartered in Cleveland, Ohio, called Highland Software. It was, very much true for them, as well as the startups that I've worked with, startups that I've worked for, peers that I have in other industries. Like that root problem of these paper cuts was the same. It sort of took no prisoners, if you will.
I hear people saying that, well, the way that we solve these problems is with collective ownership. And then I've heard other people say the opposite, which would be, no, we have a dedicated build server DevOps team. What do you think? Because it really depends on the number of people who are involved.
Yeah, that's a good question. For me, the question becomes, what is the problem and who is needed to solve it? If the problem can be solved by a group of people who own a build server, and it can be solved completely by themselves, great. They should do that. We should form that team. We should send them on that mission and let them do that work. At any point, there's a dependency where that team can't make progress until you need something from somebody else. Then you start to hear of collective ownership, which is really nice, except we all know what happens with a collective accountability is that it kind of doesn't work, and especially not at scale, right? And so you just always fall into those traps. And somehow we're surprised, and so like some of this debate to some degree is more of like a socio-organizational problem than anything else, which is what are the things that people are trying to solve? Do they have shared goals? Do they have shared tools? Do they have shared understanding? Do they have shared context? And as soon as none of those things exist, we start to like process our way through it. It's like, okay, we don't have shared context. And so what we're going to do is we're going to write a design document. The design document for how this initiative is going to improve build times serves as the both evidence and the moment in time that we get shared context, right? And so you can kind of use any example of like a process there. And I think most of that is our processes are just compensating for the fact that we don't actually know how collective ownership can work because the tools don't facilitate collective ownership. It's spread. And so we just it becomes a vicious cycle. You make improvements, and the improvements become so specific to the culture of that organization, the technology of the organization. That's partly where I think a lot of what works one place doesn't work another place. Like it feeds into that a lot.
Yeah. It's super challenging that it feels like I am finding, and this is a bit of a declarative statement, and people usually get called a fool in retrospect when making a declarative statement. But there's the idea that small teams just get so much done so fast, like what they call a 2-pizza team. Yeah. I have just always found that a team that can eat 2 pizzas, 8 people is just so freaking optimal. And then you got 12 or 15, and then it's like, well, okay, Brit, you're now in charge of DevOps, and then that's your thing. And then suddenly you go from this collective ownership, which I think is very possible on an 8-person team,
Mm-hmm.
to 20, 30 people. And then now there's chaos. What does that mean? Like, and now here I am working at Microsoft in my day job with, 100,000 people and very few 8-person teams.
Yeah. The sort of the team topologies folks, I think, have a great framework for looking at this. When you have an 8-person team and the 8-person team is the size of the company, the amount of things that team can care about, think about, the problems they can solve is very clear because there's only 8 people and the whole goal of that entire team is shared. It only becomes when you start to scale both what you're trying to do and the number of people you want to do it with, where the cost of coordination rises, the cost of dependency rises. And it would be a fallacy to say that it's simply the size of the team. Like, you can't talk about the size of the team unless you also talk about what that team is responsible for knowing or figuring out together. And if the things that they need to know or figure out together are just too big for a human being, because we're human beings, like, we need to account for that in some way, and we ignore that part, right? We just say, well, if it's 8 people, they'll clearly move faster. And it's like, well, they're 8 people, but maybe it's 4 people. Okay, we have 4 people, but there's 20 teams of 4 people who are all trying to collaborate, and there's dependencies across them. Like, how does that? It doesn't work. Like, you would have all of the similar breakdowns there. So it's as much about the size and how those people work, as well as like what are we asking them to actually do, right? That for us, specific to DevOps, is another reinforcing when the thing we're asking them to do is learn 14 technologies and 14 languages, because every language, everything solves a problem. It all solves a paper cut. The paper cuts are painful. Now, all of a sudden, the load of that team, it becomes too big. And now you got somebody like me saying, hey, I need more staff. I need more headcount. And you're asking us to do too much. We can't do it. And if you want people to be able to focus, you have to both right size the work and think about how that work fits in the bigger picture. If the picture is small, it's not as hard of a thing to do because it's a small picture,
Yeah, that's a great point. And being able to hold 8 people's work in your head is about the scope of the thing. And I think that's why we all ran towards microservices, because it was like, okay, we'll have a bunch of little small teams because no one can hold the monolith in their heads.
Yes.
But now we get these big spaghetti systems that are really giant monoliths disguised as microservices. And we're fooling ourselves to thinking that, and then, the enterprise architect will hold it all in their brain. But truly no one holds any of it into their brain, which is another paper cut.
That points more to me that DevOps is a business problem more so than anything else. Because if the microservices, if having agility should have given you some like relief in this world and should have reduced the amount of paper cuts, and either it's the exact same amount of paper cuts or maybe it's worse over time because now you're scaffolding on top of tons of microservices versus a monolith where maybe at least it's one thing to wrap your head around versus having to actually wrap your head around multiple things, then what that tells me is that we didn't talk about what the inputs are to the organization to know what the next constraints would be. So, as an example, when I think about like reorg, like the terrifying word of reorg, right? For me, reorg should be a thing that you're doing all of the time because you're refactoring how you're approaching the work. So like all of the subtle shifts that you make in staffing should just be part of the job of building and growing a technology organization. Instead, we wait, we let the problem get bad, and then we do these like massive reorganizations and hope they solve our problem. And the same, I think, can be said for re-architecting monolith to microservices, where we find a solution because we know those things in front of us and we're just solving them piecemeal. But maybe the problems aren't best solved piecemeal. Maybe is kind of that's sort of like the realization and specific to DevOps that we're kind of coming to and at System Initiative is I think the system needs to be rethought a bit, because if we only solve what's in front of us, we just maybe end up with real fast horses and we forget to invent a car,
Yeah. I've said this before, and someone mentioned it in a meeting today at work where they said, I hope that'll work itself out. And someone else retorted very quickly with, well, hope is not a strategy. So then, what is a strategy? We don't want to reorg. We've got all these paper cuts. We don't have collective ownership. You're trying to solve those paper cuts at System Initiative. Is it better visualizations, or is it visualizations that can actually change things?
I'm an ambitious human being. It is ambitious to say we should rethink the system of developing software and producing value through technology as a whole. So I tend to like the approach of pick chunks. So don't pick an isolated paper cut. Don't tell me that the hard part is an upgrade. If I only solve the problem of upgrading Kubernetes, we maybe forget about lots of other things in the way. So the size of the problem you want to solve is incredibly important. And if you do that and you sort of rethink it at the size of the problem you want to solve, you rethink it in that context, then you can kind of, reverse pyramid up into now the system is completely new because you've replaced enough of it over time, right? So I maybe more think of it as when you're rebuilding a house or you're remodeling a house, it's a lot better to know what your end state is before you start spending a heck of a lot of money. So maybe don't build a full kitchen if the next thing you're going to want to do is move your kitchen. So you need to be able to see like enough of the future to know how much time you're potentially going to waste, or at least how much risk you're willing to take on in being wrong, right? So for us, like to answer your question, like what is the solution? I can explain sort of like where the solution is in the context of DevOps, but I think the answer is it's not just one. We have to sort of work it at different sides and make sure that we're connecting all the threads and all of the conversations throughout.
Yeah. I don't know if you remember, this was a big thing in the 80s. They called the Winchester Mystery House. It's like a big haunted house that you can visit. And it was like legendary in like mystery books and stuff. And the idea was that there were ghosts in the house so that they would build doors and rooms that didn't lead anywhere in order to confuse the ghosts so that they wouldn't bother the people. And it kind of became this meme of sorts of like a redesign. I've got this door in my master bedroom that leads into, and you open it and it's a brick wall. So like when you're describing how these organizations go and build systems without thinking about the end state, it made me think about the Winchester Mystery House. And suddenly you're opening a door and there's a brick wall, and then you turn and there's an empty hallway.
Yeah. I mean, you can never actually know you never know the future. Like you can never know. All you're doing is like, I'm making the best decision I can today with the information I have in front of me. Why we aren't good at that is because the conversations we're having aren't the right conversations. So instead of talking about how much time are we willing to spend to prove that we're right or wrong, we say, well, how long will this take you to do? Because I assume that you're right. And that can be true in sort of greenlighting a feature. That can be true in, accepting a PRD or, some sort of product feature spec. At any of those stages, you could be wrong. And we don't really talk about it enough to be able to sort of say, hey, well, if we move this door here, what if we're wrong? Well, we move this door here, the house is going to collapse because this is a load-bearing wall. And we haven't stood it up another one to be able to remove the doorway right where you want to. So you have to sort of talk through those things, and we just don't. So we like to think that software is magic. We pay brilliant people to type, and they can type anything and do anything because it's magic. There's no physical constraints. There are physical constraints. We're just so abstracted from them that we now have found ourselves pretending that they don't exist. And it's a trap. It's just a trap, and we don't know how to get sort of our way out of it.
Back in the day, people would complain that using the word architecture is a bad idea because there's not a direct correlation between software architecture and home building and building buildings. But I still think it's a great metaphor. And I love the term that you just said, it's a load-bearing wall. That is so brilliant because it's like, this room I'm in right now, I love this. I don't like that wall. I'm going to just start beating on that wall without realizing there's electricity in the wall, there's a pipe in the wall. That's a load-bearing wall. I feel like our tools should be able to identify load-bearing walls within our software systems.
Yes, that is 100% true. They should be able to tell us what the load-bearing walls are, and we should know that we're going to run into it. If we're remodeling a house and we don't have the plans, and I hire an architect to come say, hey, I want an open floor plan, whatever. Open floor plan, take out this wall. If we don't have the original blueprints, and we don't know exactly what the purpose of that thing was, what do we have to do? We have to go hire a civil engineer. We have to hire somebody to come out and inspect and run tests to say, hey, well, if you remove this, you're going to have to put a, $12,000 thing in your basement that props up that floor. That might be the outcome. And so now okay, is it worth it? Is it worth it for me to have my open floor plan if now I have to go do this work? That conversation applies directly to this space.
I want to welcome Partner Hero, the Hansel Minute sponsor family. They provide customer service outsourcing that's built for the needs of scaling and high-growth startups. Partner Hero offers flexible terms, fast onboarding, and the ability to scale teams quickly, which is perfect for fast-growing businesses. In my experience, outsourcing tends to have a bad reputation as being exploitative and low quality, but Partner Hero's values-based approach will raise the bar for the outsourcing industry by investing in employee empowerment and focusing on career growth. They pay above market salaries, and they maintain a focus on quality and performance. They also offer these flexible terms for you to scale quickly, which is perfect for startups. They bake quality assurance into every program, and they have offices around the world so they can provide a truly global coverage. That means onshore, nearshore, and offshore. Outsourcing has long been available to big enterprise businesses, but Partner Hero is challenging the business as usual and bringing those benefits to startups. Short, flexible contracts, fast ramp-up times, values integrity, and expertise. If you're ready to bring in outside customer support help for your startup that feels like it's a part of your existing team, check out Partner Hero. Head on over to partnerhero.com/HanselMinutes. You can book a free consultation with their solutions team, mention you heard about Partner Hero from Hansel Minutes, and they'll waive the setup fee. So a lot of these systems are today expressed in YAML files. They're expressed in, code as infrastructure, whether it be Pulumi or Bicep or whatever. They're expressed in text. In the old days, they were expressed in Word documents, and you'd say, here's the Word document. And Word documents are notorious for not ever breaking the build, right? No change to a Word document ever broke the build. So at least the benefit of code as infrastructure, we have that. But the relationships between all these different kinds of things in DevOps is still in text. How could you solve that problem?
Yeah, so this is exactly this is one of the core problems that we're solving with System Initiative. So if we know that we want something to be versioned, which is why we put it in source control, right? We want it to be versioned, we want it to be auditable, we want it to be reviewed, we want a record, right? We want a history of changes and what has happened. All of those things are true. Those things are true in lots of places. Those things are true in a patient's health record. Those things are true with an insurance claim. So, we've already used technology to solve those problems in different domains. And System Initiative borrows from a lot of that to say, okay, what is the software solution to saying, I want this text, I want this config string, I want this, whatever the information is that you're plugging into Terraform or Pulumi or the CDK or what have you. I want it audited. I want it reviewed. I want all of those things, but I want the extra information. And that's what System Initiative does with sort of the approach in storing everything. All of the relationships are stored alongside the information itself. And so you can see and connect, okay, this open port is for this container exposed through this egress that's running, and then the container is running on this EC2 instance. That one information actually does span everything, and you can unite it all together in one place by treating these values, running it through software instead of running it through text files.
Okay, that really resonates with me. I want to make sure that I understand this because I think I had a similar problem just literally this last week. So maybe you have actually solved that problem. But I love the idea that you have identified a load-bearing wall. This port is open in this container. It's internal. It runs through, through this egress rather. It's got this virtual network between, and if you change that number, the whole thing, that 80 turns to an 8080, that site goes down. And no one knows that. Who knows that? Well, I don't know.
Who changed
Brit
it?
did that.
Did something
Brit
happen?
doesn't work here anymore, right? Mm-hmm. She's gone. That kind of knowledge, what they call it, fireside. It was told mysteries of who used to work here 20 years ago who decided that was the port. I'll just change this, right? And the house collapses.
Yes.
You're saying that you and your tools can identify that, qualify it, and make it clear for the next generation or whoever inherits that.
Yes. Because the reality is, so for the person who's making that decision, when they make it, they should know the impact of what that decision is. So when I'm deciding what this port number is, what happens? Right? So there's I'm saying what I want to be true, and I'm sort of pushing it through into the world, right? And that's where you talk about declarative, right? I want to declare this port number is the one that I want. Yes. Somebody has to say that. It's a decision to be made. But the reality is, as soon as anything in that pipeline changes, any of those relationships change, any of the values change, we already know because we can interrogate the system in which it is different to sort of reverse engineer and reconstruct the graph from the other side. It's not enough to say somebody has to go define all these relationships. You also need to say, as these relationships change, we should be able to infer and detect that and then provide that information to the person who made the call in the first place. Oh, did you know that this port is also used by this thing over here? And so you have a collision.
Yep.
And now that's new. And now that didn't exist when the decision was made, right?
This is good. So forgive me here for true story. Earlier this week, I had a certificate expire, and I'm like, I thought that this was automated. I thought I had fixed this 2 years ago, right? Like I give classes on how to fix this. So why
like raise your hand if you've been victimized by a expired cert. Like yes,
I literally teach people this, and here I am with this expired cert. So I log into the browser and I click the little cert button. I go, okay, let's encrypt. All right, okay, so let's encrypt. And then I'm like, oh, it's just expired. Okay, and then that's supposed to be from 3 months ago because they have to happen every 3 months. So I log into Azure and I look and it says cert doesn't expire for 12 months. I'm like, what in the heck is going on? Turns out I had put Cloudflare in front of Azure 9 months ago. Now, this is a company with an employee count of exactly one, me, right? This is Hanselman International. Apparently, in my wisdom, I plugged Cloudflare in front of the podcast in April, forgot about it, and I've been renewing certs in 2 places because Azure is happily renewing certs and I'm looking at the reports and everything's fine. Never wrote this down. Something expires on the Cloudflare side and that cert, so then I'm like, how could anyone have learned this? If I were gone, if I were dead, no one would ever know. How would they know?
So like you asked me about is there a solution around visualization? There is absolutely a visual component. There's absolutely a visual component to this. If you could have seen that was true, because you could visualize reality and you knew what actually existed.
Oh, because I'm opening up 2 browsers side by side in 2 different companies. This is a trivial but very real example. Mm-hmm. But imagine if I had a hybrid cloud situation, I had AWS, Pulumi, and all these different dashboards open on multiple monitors, and I'm looking at it going, how does the data flow? And it's all in my head.
Mm-hmm. Yes. So if you could see it, that would be great. But if you could experience it in any way, that's even better. So I'm like, there is absolutely a visual component to this, but we don't even have, or we've not built the systems that give us the ability to visualize. And so that I think where a lot of the time has been spent in system initiative has gone through multiple iterations, all of which I've not been here for. So, I've been here. I joined a little over 6 months ago. And part of that testing loop is, can you visualize what is needed? Can you visualize the information that somebody needs? Do you have enough in the underlying infrastructure? Do you have enough in the underlying data model to even expose, whether it's through a UI or not? It could be through a CLI. I don't necessarily care. Do you even have the information? That's where so much of the iteration for System Initiative has been, in refining what is the right way to reflect and store this so that the system is flexible enough that the relationship between the technology that we use can be graphed to then therefore be visualized, be automated, be driven through APIs, what have you. You can layer on the experiences you want, but you have to layer it on something. And today, what you're layering it on is a whole lot of paper cuts.
Yeah. And what's going to happen is, because I didn't write any of this down and I fixed it yesterday, I'm going to forget this information. The team will forget this information. Someone will quit, hopefully not me. And then I'm going to have the exact same experience again, and it's going to feel like deja vu.
And even if you did write it down, where are you writing it down?
And that's the other thing. Yeah, you stick it in Loop, you stick it in Notion. I don't know. It's on a Post-it note, in the server room at this point.
What that's sort of like for me, you have to make too many decisions that you shouldn't have to make because the systems aren't connected in the way they should be.
Right.
So maybe if you got to make less decisions, then you can make way cooler decisions in other places that would be way more valuable than having to go figure out your cert issue.
This gets to the idea of developer toil, right? This is clearly toil. Like, a tax was paid, I forgot about it, and then I burned 3 hours trying to figure this out yesterday. And then once I did, I was like, oh, and it all seemed very obvious at the time. Because to your point at the original beginning of the podcast, you're like, people make these decisions for a reason. There must have been a reason.
Mm-hmm. And even if you don't know what it was, I will just assume that you made the right decision at the time with the information that you had, because who is intentionally making wrong decisions, right? Like this idea that engineers are doing the wrong thing on purpose. Some of the vocabulary starts to smell a lot like are we trying to do the wrong thing on purpose? No, nobody wants to do the wrong thing.
And then the other thing is that once you start to become a bigger company, and then you have governance and then enforcement, then you're going to have to not just have some declarative expression of how the system looks, but then some functional enforcement to say, don't allow that because reasons.
Okay, but like what reasons though? Because I think I would love to like dig more into this. Like how would you describe sort of I'm interviewing you on your podcast. Weird question, I suppose. What are the reasons that governance comes into play for a big company?
So I used to work in online banking, and there were like literally laws on how things were stored. So you've got, whether it be, don't turn off row level encryption in the database. Everyone has their own passwords. Password enforcement is a thing. Mm-hmm. How data moves, like certain data should not ever leave this location, this physical location. Like I've got data in the German data center. That data must never go to Maryland.
Yep. So I would say, I would kind of categorize that into two things. There are either rules that you don't make that you have to play by that exist, I don't know, for reasons, security, protection, data protection, privacy laws, what have you, all great reasons. There's rules that you don't make that you have to play by. Then there's the rules that you make for yourself that you force people to play by, both of which I would sort of categorize as risk mitigation. Like it's all about mitigating risks. And so even, we talk about platform engineering and golden paths, right? The risk that you're mitigating a lot of times is that somebody does the wrong thing and doesn't know it. That is a huge, like they're doing the wrong thing, not because they think it's wrong,
right? But
because they don't know that it's wrong, because they don't have all of the information they need.
And this is where we talk about malice and ignorance are different things, right? Unless you're being willfully ignorant, it's just, I made a mistake because I didn't have the context.
Yes. And our tools force, I don't know, this is maybe an aggressive thing to say. Our tools sort of force us into this place of ignorance every day where you show up having to, well, what was I doing last? What is the problem that I need to solve now? Why didn't I do it that way before? Oh, I know. That's because I tried it once already and it didn't work. All of those are because we are not given the information we need. We're forced to be ignorant. Maybe we just shouldn't do that anymore.
That is an aggressive statement. And I like it though, because you are calling out that when you put plaster over all these walls, you can't tell what's load bearing and what's not. And it makes for a lovely looking room, but makes for a very, I don't know what wall to knock down to build my next project. And that's really, really interesting. So those are the paper cuts. Those are the things that you're trying to solve in DevOps at System Initiative.
Yes.
Very cool. Well, thanks so much, Brit Myers, for chatting with me today.
Yeah, thank you so much for having us. This is great.
You can check out all the work that they're doing over at System Initiative at systeminit.com. At the time of this podcast, you can sign up and it's in beta and the pricing is free. So go ahead and check it out. This has been another episode of Hansel Minutes, and we'll see you again next week.